For these feeds here, each of these bags hold 2 metric tons of monazite, and they're 50+% rare earth oxides, so a very, very high value feedstock here.
Here at the White Mesa Mill in Utah, mineral company Energy Fuels is processing rare earth elements. These materials are crucial to modern-day technology. Rare earths refer to 17 elements on the periodic table whose atomic structure gives them special magnetic properties. Rare earth magnets power everything from electric vehicles and wind turbines to defense equipment, data centers, and high-tech consumer electronics.
So now we're inside our processing facility. Our rare earth ores enter here. We left them up with a big crane, and we dumped them into these tanks here behind me. These are 100,000-gallon tanks, and once they get into these tanks, we take them through a variety of processes that includes cracking, leaching, solid liquid separations, and some impurity removal.
The United States used to be an industry leader of rare earth production up until the 1980s. But for the last several decades, the US and the rest of the world have largely depended on China for the majority of their rare earths. Now, escalating trade tensions between the two countries have forced the US to seek to develop a domestic supply chain, after China enacted stringent export controls of rare earths back in April.
The United States is so dependent on a number of these critical materials, we are absolutely held hostage by companies that are geopolitical foes.
This is the feedstock to physical AI. We've had, on your air, we've had Jensen Huang, Elon Musk, and many others talking about robotics, drones being the largest industry in the history of the world. Well, rare earth magnets are essential. And so if we don't bring this supply chain on now, then we're really leaving trillions of dollars at risk.
This is all hands on deck warfare right now between the US and China. It's a competition that is an existential competition in my view, and so nothing is off the table.
Global demand for rare earth permanent magnets is expected to more than double by 2035. But can the US wean itself off of Chinese rare earths? CNBC spoke to experts and stakeholders about what it will take to mine and process rare earths domestically. Contrary to their name, rare earths are abundant in Earth's crust, but they're often found commingled with other elements rather than in large deposits. Worldwide, China has the highest concentration of rare earth reserves, followed by Brazil, India, and Australia. The US ranks 7th in terms of available reserves. The process to separate rare earths from these other minerals is complicated, expensive, and requires specialized equipment and technical skills. The mining of these minerals also comes with the risk of potentially significant environmental damage.
The mining of rare earths, especially in China, is considered very polluting. When they extract these heavy rare earths, what they do is they use really harsh chemicals on the ground to extract this material in the form of clay, and that material ultimately seeps into the ground and pollutes the water body and kills the vegetation. And if you were to extract light rare earths, which are primarily concentrated in something called as hard rock mines, you need to use really harsh agents to blast off the rocks, which release clouds of dust, and they potentially pollute the entire environment.
Experts say that lower labor costs, weaker environmental standards, and strong government support have all helped Chinese companies become dominant in the rare earth supply chain.
About 70% of the actual mining of these materials rest in the hands of Chinese companies, and 90% of the processing. That's an incredible amount of dependency when you think about how important these materials are to running a modern economy.
China has had the monopoly in this market for a really long time. The reason being is that the cost of production of these separated rare earths and magnets is very low in China, and any producer outside of China cannot enter the market because these prices are what we called as sub-rational prices.
Experts say that the current US-China standoff with regard to rare earth elements can be traced back to 2018. During the first Trump administration, the US levied heavy tariffs on Chinese goods in an attempt to hamper China's Made in China 2025 initiative, which focused on transforming China into a global manufacturing powerhouse, particularly with regard to high-tech industries. During the Biden administration, the US also enacted restrictions around exports of advanced microchips to China, though these restrictions have since been reversed. The final straw in the collapse of trade relations between the two countries seems to have been the enactment of more tariffs by President Trump during his second administration. with tariff rates on Chinese goods reaching a high of 145% in April.
On April 4th, China decided to retaliate to this tariff escalation by implementing an export control on 7 medium and heavy rare earths. Also, this restriction applies to sending the material for any dual-use items. What this means is that any military organizations were considered as primary target. So defense supply was completely cut off.
China has slowly built out this export control toolkit, really mimicking and copying U.S. export controls to hit back at U.S. and other countries for actions that China believes are unfair to China. So although we are seeing it actualized over the last 7 months, China has spent the last several years building out this toolkit.
The Chinese export controls on rare earths disrupted a number of industries, with the EV sector being particularly hard hit.
Suzuki in Japan had to stop their production. Ford had to stop their production. Tesla raised concerns about their supply being disrupted because they had submitted applications for their humanoid production, and China assumed that it would be used for military applications.
While initially slow to approve licenses for exports of its rare earth materials, China has picked up the pace. This growth in exports came after Washington and Beijing agreed on a trade framework that included easing controls on Chinese rare earth exports in exchange for the rollback of some American tech restrictions for shipments to China. Still, experts say U.S. dependence on Chinese rare earths remains the country's biggest weapon in the trade war.
Once we can reduce it as an effective weapon, then we can get back to normal trade. But right now, for the Chinese, it's an extremely effective cudgel because we are so dependent.
The United States seems to be getting serious about establishing a domestic rare earth supply chain. In July, the Department of Defense announced a $400 million investment in U.S. rare earth miner and producer MP Materials. MP Materials owns the only operational rare earth mine in the U.S. at Mountain Pass, California. Goldman Sachs and JP Morgan also backed the company with a $1 billion loan to fund the expansion of MP Materials' magnet-making operations.
The deal consists of 3 main parts. It's an investment in MP. It is price support for our commodity because, as we know, the Chinese have kept the market well below levels where anyone can adequately make money or get a return on capital in the free market. And then lastly is an offtake contract for us to accelerate investment. And so when you add up this package, what it is going to significantly accelerate the development of this entire full supply chain.
MP Materials says that this investment will allow the company to ramp up production of its rare earth magnets from 1,000 metric tons in 2025 to 10,000 metric tons by 2028. The company already has one magnet-making facility in Texas, but is planning a second U.S. plant it calls 10X to help it scale. The Department of Defense declined to be interviewed for this story, but in a statement to CNBC, a defense official said, DoD selected a unique approach to this agreement to account for the difficulties in establishing and sustaining production of critical rare earth magnets in a market environment in which China controls much of the supply chain. By leveraging preferred equity, loans, price floors, and other approaches, DoD is ensuring access to critical defense capabilities while also sharing the risk inherent in a commercially dominated market space. The official went on to say that the Defense Department has invested almost $540 million to support the domestic and allied rare earth element and critical mineral supply chain.
The Chinese have spent so much time building out their state-owned enterprise in this sector, fully integrated, from mines to buyers, price support, all sorts of things. We have tried to rely on just the pure market mechanism to do this. MP Materials, however, I have to admit, is a game changer.
DoD has given a price floor commitment of $110 per kg of NdPr, which is almost double of the current prices. So this $110 a kg will obviously make MP Materials more bankable, but it will also enable a lot of these junior miners and marginal producers to gain investments and come online at these prices.
Shares of MP Materials soared by about 50% following the announcement and have continued to climb. Other projects are also in the works. In Wyoming, Ramco Resources is working to extract rare earths from a coal mine the company had purchased about 15 years ago. Durham, North Carolina-based startup Vulcan Elements has said that it will make rare earth magnets for the U.S. military. Meanwhile, in San Marcos, Texas, rare earth magnet maker Novion Magnetics has a deal to make rare earth magnets for Japanese motor company Nidec. Mark Chalmers says his company, Energy Fuels, began refining rare earths about 5 years ago at their White Mesa facility in Utah. The company has historically mined and refined uranium, a radioactive material, and realized they could also use a similar process to extract rare earths from monazite.
This is our most newly arrived monazite. This comes from Georgia, Chemours company. This is a byproduct of their heavy mineral sand mines in Georgia, and they're shipping it to us. We're using monazite ores, one, because it's a very cheap feedstock. It also has a really good distribution of rare earths. Monazite is radioactive, and not many places in the world are able to process it. And where we're a uranium facility, radioactivity is something that we're very accustomed to handling, and so it's suited us very well for a lot of reasons.
The stock price of Energy Fuels has also benefited from general interest in rare earths. The company produces neodymium praseodymium oxide, or NdPr material, at commercial scale for use in permanent magnets, but says that it can expand its offerings to include other rare earth elements with the right financial support. The company is already running pilot-scale production of some of those other rare earth oxides.
Right now, we have the capability to process up to 1,000 tons of NdPr, and to put that into context, that would be approximately 1 million electric vehicles or hybrid vehicles. Our plans are, in what we call phase 2, to increase that up to 6,000 tons of NdPr, which would be up to 6 million electric vehicles. We also have the capabilities and are advancing our abilities to produce a number of the other heavy rare earths, mainly dysprosium, terbium, and samarium, and other elements as required by the United States government if they choose to have us recover those products in due course with the proper incentives.
Alternative sources of rare earth mining are also being explored. One of those is recycling. Apple is betting on this technology. In July, the phone maker announced a $500 million investment in MP Materials, whereby the company would buy rare earth magnets produced at MP Materials' Fort Worth, Texas facility. The magnets will be made from recycled materials, with shipments expected to begin in 2027. Deep sea mining is also being considered, though that technology is still in its infancy and comes with its own environmental concerns. Some U.S. companies are confident that they can meet the country's needs for rare earth oxide supply.
We have about 1.7 million tons that we've discovered using about only a third of the site. So the other 2/3 we expect to have similar type of results. The U.S. only uses 10,000 tons a year. So at that basis, we've got probably well over 100 years of supply just in this one spot.
We believe that we will be able to produce between 50 and 100% of the United States requirements of these rare earth elements in approximately 3 to 4 years' time.
But experts say the U.S. is far from breaking its dependence on rare earths from China, especially when it comes to finished rare earth magnets.
There's a lot of effort going on to build a supply chain that is more resilient and that is diversified from China. However, this is not enough. At the moment, USA is importing almost 30,000 tons per annum of magnet, and that is expected to stay through up until 2030 as well, even though they are building their own capacity. That is because the demand for rare earth permanent magnets is also increasing.
Additionally, China's chokehold on rare earths extends beyond the minerals themselves.
We talked about earlier reagents and the need to use reagents in order to separate some of this material to get magnets. And well, reagents, most of that chemical is still in the Chinese supply chain or in countries that rely on the Chinese supply chain. We've lost a lot of our metallurgical labor skills. Most of that exists in China. So workforce development is going to have to be a part of this deal at some point.
Despite these challenges, McNeil believes that U.S. commitment to a domestic rare earth supply chain could pay off.
I don't think that it's realistic to think that this is going to get done in 2 or 4 or 5 years. I think the challenges are too great, and I think the needs are still very, very high. If we're showing incremental progress, if we're showing resolve, if we're taking words, policies, legislation, rhetoric, and translating that into real action, I think the signal that it sends to China is enough to signal China to change its policy approach.